Welcome to our second video on measures of frequency, and here we are going to be looking at some measures of morbidity and mortality. Remember, in epidemiology, a lot of times we're wondering about how many people are getting sick, which is morbidity, and how many people are dying, which is mortality. And specifically in this video, we're talking about unstandardized. And in the third video, we'll talk a little bit about standardization. So if we're looking at just the basic form of those measures of morbidity and mortality, as a quick review, we are talking about incidence or new cases, prevalence or existing cases, and each of those we can look at in terms of the count or as a way of comparing between populations or over time. We can think about the ratios, the proportions, and the rates. And the vast majority of what we do in epidemiology is in proportion and rate. And so the things that I'll be sharing with you really have to do with generally proportions and rates. Rates are events per year, whatever those are, new illnesses, deaths, births, those kinds of things, as a per year kind of a thing. And proportion is really not looking at that it's just looking at either the existing over the total or the new over the total that happen. Now, what I like to do is I like to give a general framework of how these equations work. And it goes like this: of a certain population, a group of people, how many are something. And if you are able to take a scenario and put it in this format, you will know the denominator and the numerator of that particular equation. So if you think about the kinds of groups that we can look at, first of all, we start with the total population. And that is, a lot of times, that's going to be our denominator. So of the total population, how many have diabetes? So it could be that's sort of a morbidity. Of the total population, how many died in that particular year? And that's called the crude mortality rate. So here we have our total population. But I like to break it down into smaller increments or steps, because there are a variety of things that we can use as that denominator data, and there are a variety of things that we can use as our numerator data. So of the total population, a subpart of that is those who have not yet had the disease that we are, or the exposure, or the whatever that we're interested. And of those who have not yet had that disease, there's a subpart of that that is exposed to the disease. So not everybody who's exposed, not everybody who has not yet had it automatically is exposed. In other words, these are subparts of each other. Of those who are exposed, only a subpart of those actually get sick. And that getting sick could be subclinical or clinical, but we know that not everybody who's exposed to something, some disease, like let's say an infectious disease, not everybody gets sick. And of those who get sick, some of them die, some of them become chronically sick, and some of them get well. And so this subpart of the getting sick could be dying, it could be having chronic disease. So these are all little subparts. And what we do then is we pick a subpart and we pick a denominator. So for example, we could say of the total population, and that's our denominator then, right here, what proportion die in a given year? And that's called our crude mortality rate. So how many die? Of those who are exposed to a particular disease, what proportion get sick? And that's called our attack rate. So do you see how we can be very flexible about what we use as our denominator and our numerator? Your task then is to look at all the different kinds of things that we can use as measures of morbidity and mortality and figure out where they fall in here. Of those who get sick, what percent of those die? That is called our case fatality rate. Now, both of those things, the attack rate and the case fatality rate, have the word rate in them, but they are not rates. And this is that sort of misunderstanding or using those terms very flexibly. And even strict scientists use those terms incorrectly. So I would not spend a lot of time. You can understand the fact that we're using them incorrectly, but still we are so ingrained in using attack rate and case fatality rate that that's not going to change. Another way of thinking about it is we can use even within each of these levels, like let's say we pick this group that dies. Of all the people who die, what percentage die from diabetes? What percentage die from heart attacks? And that is called our proportional mortality rate. So even within a level here, we may choose to, like let's say here we are within this level right up here, of those who die, what proportion die from a specific cause. That really is giving us it'll tell us what's the number 1 cause of death, what's the number 2 cause of death, what's the number 3 cause of death, and that kind of thing. And that's called the proportional mortality ratio. So there are a lot of ways that we can flexibly use this concept right here to be able to describe a number of different things that we see in epidemiology. Let's go and talk about some specific things. Of the total population, what proportion die? That is called our mortality rate or our crude mortality rate. And notice that we're calling it a rate. Usually we're talking about per year, and so how many die per year, and so that is a rate. We may not be calculating the person time for each individual, but we may be estimating that by using the number of persons at mid-year as the persons at risk. And so again, we're really struggling sometimes with that denominator data, but we're trying to get at something that is a rate. So both of those, we may have something called a cause-specific mortality rate. And that is of the total population, what proportion or what, how many die from that specific cause. So say die from stroke, die from heart attack, die from cancer. So that's our cause specific. We can also do age specific. And so remember, here we are, we're of all of those people who are a specific age, let's say 45 to 54, or of all those who are age 65 and older. How many die in that particular year? So knowing what your denominator is and how it is and what it is that you're measuring for the numerator can help you figure out exactly what it is that you're after. There are some other rates that are very important to us in terms of pregnancy and birth. And those are the fertility rate and the birth rate. Fertility rate often is of all women who could have a baby, age, a lot of times we call that 18 to 45. Sometimes we extend that 15 to 45. We sometimes extend that age 15 up through 49. How many births do you have per 1,000 women in that category? And fertility rate is one of those things that is sort of flexible. Different people have different definitions for it, so just be really aware of what their definition is for that. Also, we may have the birth rate, and so sometimes the birth rate is expressed per just per 1,000 population. Sometimes it's per some other subcategory, so just being aware of exactly how that is used. In terms of infants, that's a very precarious part of a person's life, and depending on where you're born, the risk of dying in that first year can be actually pretty high. And so we have what's called the infant mortality rate, and usually the way it's calculated, it is not a rate. Ask me about that sometime. Usually the denominator for that is not all the infants who die are not included necessarily in the numerator is not included in the denominator. And that's because of the way we break up the years. But we still use it as an approximation for the infant mortality rate because we don't have any better data. And by infant mortality rate, by that we mean of all infants who are born, how many die before their first birthday. And so that's up through day 364 of life, because at day 365, that infant turns into a non-infant. In other words, on their first birthday, they are no longer an infant, so they can't qualify for infant mortality rate. We also have fetal mortality, and that can be either a rate or a ratio. With the fetal mortality rate, the denominator includes all the fetal mortality, and the fetal mortality ratio does not include the fetal mortality incidence or the number of fetal deaths. So basically the numerator, or this how many fetal deaths did we have, for the rate, the denominator is all infant births during that year plus the fetal deaths. For the ratio, it's just divided by infant births during that particular year. So we have two slightly different things, and they are either ratios or rates. And the ratio will always be slightly higher because the denominator does not include as high of a number. So the same thing happens with perinatal mortality, and we'll get to that in a minute. So here we have our infant mortality rate, our fetal mortality rate. And for infant mortality rate, we actually need to break that down into neonatal and post-neonatal. And an interesting thing happens here. Neonatal is days 0 through 27. Post-neonatal is days 28 of life through 364. Neonatal plus post-neonatal actually equals infant mortality. So the neonatal deaths plus the post-neonatal deaths equals the total infant, because infant is 0 through 364. I like to share a little bit about kind of how that works. Post-neonatal tends to be, of the total infant mortality rate, tends to be about a third. And so if your infant mortality rate is approximately 6, you would have 2 post-neonatal and 4 neonatal. So neonatal tends to be about 2/3. Of the neonatal, about 2/3 of them tend to be during the first week of life, because this is a full month. And of those that happen during the first 7 days, days 0 through 6, approximately 2/3 tend to be during the first day of life. And of those who are during the first day, about 2/3 tend to be during the first hour of life. And of those that are during the first hour, about 2/3 of them tend to be during the very first part of that hour. So very early on. It's a curve that if you were to graph it, it drops off pretty quickly. So the very early part of an infant's life is this really dangerous part where you have mortality happening, and then it drops off. Now, during the later part of the infant's life, until they become a year old, depending on what country you're in, that curve may be shifted up or down. So if you're in a safe country for infants, then it's not as dangerous. And if you're in a country that doesn't have ways of protecting infants from dying, and it's more risky to live there as an infant, then your curve will be higher overall. But as a general rule, post-neonatal tends to be about a third, neonatal tends to be 2/3. So that's just kind of an interesting little fact. Now, of this neonatal, days 0 through 6, like I said, is sort of the early neonatal time period. And do you remember how with fetal mortality we could actually look at 20 weeks all the way until term? Or we could say late fetal mortality is 28 weeks all the way through term, which is 40 weeks is a general length of gestation. This part right here, this 28 weeks until what would be considered full term, plus the early neonatal time period is really a reflection, that combination, that time frame is really a reflection of the quality of the healthcare system that the mother and the baby are living in. And so we call that has a special name, that's called perinatal. That's the perinatal period. And any deaths that happen for the infant during that time frame, late fetal plus early neonatal, are called perinatal death rate or perinatal mortality rate. And so a lot of times we will use these particular measures for a specific thing, and that particular measure, perinatal mortality rate or perinatal death rate, really reflects the quality of the healthcare system. There's another one that's related to fertility and infants and that kind of thing, and it really is the maternal mortality. And these are all of the deaths that for the woman that are related to pregnancy and childbirth. And you can look up and see that some of the top causes are hemorrhage, eclampsia, things that happen around the time of the birth that the mother can actually die from. And so depending on where a person lives and what kind of health care they have access to, that may impact the maternal mortality for that particular country. And so providing that's kind of a dangerous period of time for the mother to be alive. So maternal mortality is not all women who die are mothers, and so it's kind of a little bit of a misnomer, but we still use that term for that particular time frame. So those are some of the common things that would be considered measures of morbidity and mortality. Think about it in terms of all the pregnant women, how many die? So that's where we're looking here at maternal mortality. If you can think of who that risk group is, and then what percent have that particular outcome, then a lot of those will not be so much about memorizing, but they'll be a little bit more about really understanding what they're getting at. And if you're reading something and they use a term like incidence, and you're like, I'm not sure exactly what they mean by incidence because it can mean so many different things, then just understanding their description of it will give you a better picture of what exactly they were measuring. So that concludes, there was one other thing that I was going to talk about, and that was in terms of if you were to have some kind of a question on like a boards type scenario, a lot of times they will ask the question. Now, let me get another color of pencil here just so that I can add this. Which of the following is the formula for, and then they list literally something. Which of the following is the formula for crude mortality rate? Which of the following is the formula for point prevalence? which of the following is the formula for fetal mortality ratio? So that's actually one of the questions that's listed on the CPH website under their kind of practice questions, which are pulled from the actual test. And so you can imagine that all you have to do is change which of the following is the formula for, and pick a different one. It's so easy to create that kind of a question. The other kinds of questions are what I call scenario questions. And so they'll give you a scenario. They'll say there's a city with a population of this many people, and such number die in the year. And then they'll ask you, what is the mortality for that particular city for that year? So knowing the formula helps you be able to answer the questions about the scenario. However, the scenario takes it to that next level where you really need to understand when they tell you certain descriptors, oh, that is the number who died. That is my how many for my numerator. So being able to extract that information and not just knowing the definition of it. So those are really just two different ways of looking at that kind of a question. So I hope that's been helpful as you're studying. Always just sort of put those questions in terms of my total number, how many had this particular event or exposure or outcome. So that concludes this video.